Okay, so we are in Regression and Other Stories, Chapter 1, going through the end of chapter questions. And I am skipping questions 1.3 to 1.8 just because they ask you to do things that are of interest to you personally, and the answers I feel are just going to be too variable to be very useful. And similarly, I'm skipping the last question, 1.10, for the same reasons. But that does leave us with question 1.9 here. So here we have the question. So let me just summarize it. You can read the question for yourself. But earlier in this problem set, way earlier, in fact, it was the first question, we were told to generate some data from these little helicopters that were cut and folded out of a single piece of paper, where we could adjust the width of the wings, I think, and the length of the body, and then have the time that it took these helicopters to fall to the ground. So in this question, where are we here? Okay, and so in this question, we are supposed to kind of put ourselves back in that frame of mind. And so we construct 25 helicopters and measure their falling times. Then we fit a linear regression, or we're supposed to assume that we're doing this. So we fit this linear regression right here. And then we want to use the fitted model, which is just this model minus the error, right? So we fit this or we use this estimate to maximize the time outcome. Okay, and so there's a couple of questions here, which is, why will this approach fail? And then we're asked to suggest a better model to prevent the failure mode from happening. So this is a pretty open-ended question, I feel. And so if your answers vary, I hope that you will put your answers in the comments. But here's my thoughts on it. Okay, so my first thought is that linear regression is not really the tool that we would use, or not the only, at least not all by itself. It's not what we would use necessarily to maximize an outcome, right? So just to give you a sense of why not, imagine that our estimate for beta 1 is 1, okay? So it's greater than 0. Well, then that would imply that if we wanted more time in the air, well, all we have to do is increase the width, because for every unit of width that we increase the dimension of our helicopter, the more time we get aloft, okay? But of course, we could get out to ridiculous dimensions here, in which case the equation will just completely break down, right? Like if we have wing width that is 4 feet wide, it's not, well, it might not be a helicopter. Or just take it to an even, if that doesn't convince you, 100 feet wide, right? It's just without bound, okay? So that's one reason why this wouldn't really work. But and so really we might use something like linear regression to fit a model, but then we're not using linear regression to maximize time. We would build a curve maybe with linear regression, and then use something like calculus, maybe taking the first derivative of the equation that we got here, and then finding where it zeroes out to find the maximum, and so on and so forth, to maximize time. So that's one thing. So why will this approach fail? Well, one reason is that linear regression probably isn't the tool, or at least not all by itself, that we would use to maximize anything. In fact, we're minimizing the error of the fit of this line to the outcomes. Okay, so that's one thing. Another thing is that our helicopter's construction is constrained, or the dimensions of it is constrained, okay? So width and length cannot vary indefinitely. right? They're coming from I think 8 by 11 piece of paper or something like that. And so there's only a finite width that they can achieve, or a finite length that they can achieve, and they're further constrained because there's a relationship between width and length. In other words, the more paper I'm using to increase the width of the paper, I have less paper for the length of the body, and vice versa. Okay, so this regression doesn't pick up on those constraints. There's an additional constraint here, which is, or possible. I'm not a physics person necessarily, and so, but I suspect that the time aloft for these helicopters actually has to do with some kind of ratio between the width and the length, and probably some other variables like the weight of the helicopter and so on and so forth. So, so anyway, none of that is being captured in this regression. Okay, so how might we start to fit a better model to all of this? Okay, well, at the very least, we probably need an interaction term. Okay, that accounts for some kind of relationship between length and width. Okay, and so we could do that by adding something like a beta 3 width times length term, right, to the end of this guy. Okay, so we could estimate that type of an equation. So that would be one thing that we could start to do. We might also consider transforming the width and the length variables to something that reflects the constraints that's imposed upon them. All right. We may even add additional variables that somehow reflects like width, like the ratio of width over length. Okay. And then finally, we may find that linear regression is really not the best tool to use here. We may need some kind of nonlinear regression, or we may need nonlinear terms in here, such as width squared or length squared or something. But anyway, there's a lot of things that we could do to begin to play with the model, but we definitely need to address the constraints that are imposed on the model, as well as the relationship between length and width.